Okay. Good morning, everybody. Today is 2nd December 2020. The day is Wednesday, and my name is Ferhan Mazher. And right now, I am with the 10th Cambridge class. And the subject we are studying is Physics 5054. And we have decided to do past papers. This is 11th Cambridge class, so we are doing the past papers. We will do section B of this paper. In this session, we are attempting the section B of this paper. So the next paper we will do in this other section we will do in another session. So okay, let's start directly. Section B, winter 2019 paper. The variant is 121 paper we are attempting. A small electric component in the circuit needs to be protected from a strong external magnetic field. Describe how this is done and state the material may be used. Okay, so if you want to protect any component or anything from external magnetic field lines, the process is very simple. What you do, you make a ring of soft iron. What you will do, you will make a ring like this, a ring of soft iron, which is a magnetic material, and you will put that component inside that ring. Okay, so when you put the component inside that ring, what will happen? If magnetic lines, external magnetic lines will come, they will pass through the material of the iron ring, and from the other side they will exit. They will not enter inside the area which is inside the ring. This is called magnetic shielding, or this is called magnetic screening. Do you understand? It's a 2-mark question.
Yes, sir.
So let me show you the marking scheme also. I have the marking scheme with me right now. Let's open it. And okay. So hopefully this is visible to you on your screen. Okay. Question number 8. So he says 2 marks. And surround the component with a box or use of the iron mentioned. Surround the component with the box of iron. Okay. So 2 marks. Can you write the answer? Will you write the answer? Hello? See, the marking scheme is on your screen. If you write the answer and then you tell us the answer, then we will see if your answer is right or not.
Sir, then मैं बताऊं?
Yeah.
Surround the component with iron, soft iron, and surround the soft iron with a wooden box.
You see, the wooden box will have nothing. The wooden box will not be able to stop you know, the magnetic lines. Wooden box will not be able to stop the magnetic lines. So the wooden box thing should not be there. The second thing, surround
ठीक.
the component or whatever that thing is with the soft iron ring. Okay, it's a ring like this. Put it like this and you put inside the component. So rephrase your answer.
Okay, sir.
Good morning, sir.
Good morning. everybody should have the booklets with you. We are working on the winter 2019 2-1 paper. It's a zone 1 paper, theory paper, paper 2, but the zone is 1. And today we are attempting its section B. We are trying to understand that how this thing will go.
October, November 2019.
Yeah.
Okay, sir.
Section B.
Question number 8.
Yeah. The first part we are doing.
For who, sir? Question.
No, we are working on its answer, A part. So you take a component and you take a soft iron ring, you put the component inside that ring, and this will help us in the magnetic shielding. Anybody has written answer?
सर समझ नहीं आई.
You see, you take a soft iron ring. Ring is of this shape. And you put it like this. And for example, if you have a component and you want to keep it safe from the magnetic field, external magnetic field line, you just put that thing inside that ring. That's it.
Okay.
Because the soft iron is a magnetic material, so the magnetic lines will not be able to enter in the area which is inside the ring.
Yes, sir, समझ आ गई है.
So just write the answer, just tell me, so I can check this. Shafia, you have not. You are supposed to rephrase your answer and. If you have written your answer,
We will take soft iron ring and will place the component which needs to be protected from the strong magnetic field inside the iron ring.
That's good. That's it.
Okay, sir. B part.
Okay, can we move to the next question?
Yes.
Okay. So what it says,
electromagnets have many domestic and industrial applications. In this space, draw a diagram of a simple electromagnet.
okay, so you want to draw the diagram of an electromagnet. And the diagram is very simple, let me take out the paint. How we draw electromagnet, okay? New. So the electromagnet is very simple. You see, for example, if I take this is a steel rod, okay? And let me take a copper wire and wind around it, okay? This diagram you will make, okay? Write here steel. You can write here the steel rod. Okay. This is steel rod. This is okay. So make this diagram in your copies. Okay, he says, let me reduce the marking scheme. Okay, so solenoid core, iron core. Okay. It's a 3-mark question, okay? You have to draw that electromagnet and you have to label the things also. Okay? So, for example, here you can write steel, or you can write, you can write, for example, you can write battery. Show a switch also. You can show a switch also here. For example, let me show switch here. You can show a switch also. Hello, girls, are you with me?
Yes, sir.
Okay. Shafia, it's a 3-mark question.
हाँ जी सर मैं ड्रॉ कर रही हूँ.
सर ये जो स्विच है वो हम कहीं भी बना सकते हैं ऊपर नीचे किसी साइड पे भी बनाना
Yes.
Yes,
You
sir.
can make it on the other side also. Like I have made it on the positive, from where the positive terminal, the positive terminal is. You can draw it on the negative side also.
ओके सर.
Next part.
Okay. Are you done with this diagram?
Yes.
Let's check its marking scheme also. It's very carefully see on the marking scheme what are the marks. Solenoid, you have to draw. Solenoid is that the spiral thing. Okay. And then you have to draw a DC power supply you have to show, and a switch you have to show. These 3 things have 1 mark. So you have to show core, and you have to, if you write iron core, you get both the marks. Okay. For example, I told you to write there steel. You can also write the rod on which the wire is wound. Name that rod. That is made of iron, or you can say that is made of
Steel.
It's better to use. It can be of steel, but the best, because the steel will become permanent magnet. It will not lose its magnetism once you switch off the light, electricity. It will be better if you name it as iron, because the iron is a temporary magnet. It becomes temporary magnet. For electromagnets, the iron is the best thing. So instead of saying steel, use iron.
Okay.
So if you are done with the diagram, then we can move to the next one.
We are done.
Okay. He says state and describe in detail one use of an electromagnet.
To make permanent magnets.
Transformer.
In the transformer, do we have magnets?
Yes.
The transformers which we have studied in your course, they do not have electromagnets. They have electromagnets. Oh yeah, they have electromagnets, but you will have to describe that thing also. You see, have you seen a crane?
Which crane?
Which is used in the scrap yard?
यस सर, वो स्टील की उसका मैग्नेट होता है और फिर अंदर से वो जो मेटल का
Wait. You see, the crane has a
स्टील
that is not of steel, because with the steel we have a problem. This
परमानेंट
is
मैग्नेट बन जाते हैं.
steel will become permanent magnet. So when you will switch off the light or electricity, it will not lose its
आयरन
magnetism.
यूज करेंगे.
Yeah, we will use. This is a crane, and this is its boom, and here is the head of the boom. It is an electromagnet. It is used in the scrap yard. You know, when you provide this with the electricity, this head, you provide it with the electricity, is made of iron. This becomes an electromagnet. So what will happen? Whatever is the iron pieces here, or whatever is the electromagnetic material here, when this red thing will become electromagnet, this will be attracted to the head of the boom, and it will pick it, and wherever you want to drop it, you switch off the light or you switch off the electricity, and what happens? The scrap, which is iron or a magnetic field, that will drop on the ground. Do you
Okay.
understand what I said?
Yes.
You can write this. You see, there are 3 marks. 1 mark is telling the name of the appliance which uses the electromagnet. What happens when the electromagnet is switched on, and current, and 1 mark is for saying that the current magnetism. Okay.
सर ये पॉइंट नहीं समझ आए, ये दो नीचे वाले.
So for example, when you switch on the current, okay, the head of the crane will become electromagnet.
सर इस मशीन का, ये जो आपने चीज बनाई थी, इसका नाम क्या है?
Crane.
और वो जो ऊपर मैग्नेट है उसे आयरन रॉड कहेंगे या आयरन बार?
Iron, the head is made of iron.
ओके सर, और फिर वो इलेक्ट्रोमैग्नेट बन जाएगा और वो मेटेलिक ऑब्जेक्ट्स ऊपर ले जाएगा. लिखते
For example, the things which are made of the material which are magnetic, which are, I mean, the materials which are magnetic, they will be attracted. Magnetic materials will be attracted to the head of the crane. So where you want to drop them, you go at that place and you switch off the current. You have to describe all these things. Let me show you.
कुर्सम
जी.
ये बुकलेट 2.1 कर रहे हैं ना?
यस.
जोन कौन सा क्वेश्चन है? कब से ढूंढ रही हूँ, मुझे मिल नहीं रहा.
सेक्शन बी, क्वेश्चन नंबर 8.
अभी हम 2 पार्ट करें बी का.
सेक्शन बी में क्वेश्चन नंबर 9 है.
8 भी है यार.
Hmm. Yeah. Let me find out from here.
सर मैंने लिख ली है.
Mm-hmm.
Crane used in scrapyard. Crane has a wire on which iron bar is attached. When current is provided, iron bar becomes electromagnet and it attracts magnetic material. Crane travel where these objects need to be deposited. When the current supply is cut off, objects fall as iron is demagnetized. ठीक लिखा है.
Yeah. Can you see this on your screen?
Yes sir.
You can read this also.
सर ये ब्लर है थोड़ा सा. आप पढ़ दें.
Now, he has written these large cranes are used to pick up and move metals containing things such as steel and iron, which is primarily found in recycling plants and junkyards. The electromagnetic cranes work by using a magnetic field that is created by an electric current that can be turned off and on whenever it is necessary. The electromagnet consists of an iron middle with a wire wrapped around it, which is where the electric current travels. I'm just showing you that this is one use of the electromagnet. Shafia, are you done?
Yes sir.
Okay. Anybody would like to read her answer?
मैं पढ़ती हूँ. Crane used in scrapyard. Crane has have a wire which is wrapped around iron bar. When current is provided, iron bar becomes electromagnet and it attracts the magnetic material. Crane travels where these objects need to be deposited. When the current supply is cut off, objects fall as iron is demagnetized.
Okay. Good. Very good. Deposited. You use the word deposited. Okay. Should we move to the next part? Can we move to the next part?
Yes sir.
Yes, sir.
Okay. So figure 8.2 shows a solenoid connected to a sensitive ammeter. explain what is observed on the ammeter when a student inserts a north pole of a bar magnet slowly into the right hand end of the solenoid. Okay, let me take this diagram. Okay. So let's see what happens. It's a 3-mark question. Okay, so what they are saying that they have a bar magnet. So here we have a bar magnet, and this is the north of the bar magnet. This is the south of the bar magnet, and they are bringing the bar magnet to this side. Okay, this is what he has told us. So when you will bring a bar magnet near this coil, and we know that when a north pole is approaching this right side of the solenoid, so it's natural that this coil will try to stop this motion. It will try to oppose this motion. So to stop this motion, here a north will be created. And on this, a south will be created. So north means that, remember this thing, north means that, remember this diagram, okay? What the north means? North means that anti-clockwise current will produce here. And the south means a clockwise current will be here.
सर अगर एन पोल निकलेगी बाहर तब भी एंटी क्लॉकवाइज करंट प्रोड्यूस होगा नॉर्थ पोल जब विथड्रॉ करेगा
No. So the basic idea is this, that when you bring a bar magnet close to the right side of the solenoid, the right end of the solenoid will become north. And obviously the other side will become south. And we know by this diagram, which I draw in green color, that when the right end of the solenoid will become north. And if you look at that face, look at that end, the current will be moving in the coil in such a way that it will appear to you that it is moving in an anti-clockwise manner. So the current will be moving in an anti-clockwise manner. Sorry?
सर आपने कहा डायग्राम मैंने बनाया कहाँ बनाया है
This paint file is not showing on your screen.
No.
No?
सर आपकी शक्ल नजर आ रही है
Oh no, internet is the problem with it. There is a problem with the internet. What can I do now? You see, now what you see?
Nothing.
Nothing.
सर कुछ नहीं होता आप क्वेश्चन कराएं
the thing I am explaining is are you able, where are the rest of the people? They are totally quiet. Can you see this paint file? Or nobody can see it?
सर नहीं नजर आ रहा.
सर नहीं नजर आ रहा है. आपकी फोटो भी सर रुक जाती है.
Okay. What you see now? Now is the paper is showing or
पेपर.
okay? Why not the paint is showing?
सर आपने शेयर माय स्क्रीन नहीं किया, शायद यही मसला है.
Wait, stop presenting. See, I am presenting my whole screen. That's why you are able to see the things I'm opening. Okay. So I stopped it and I have done again. Yeah. Can you see now?
No sir.
No.
The paint file is not showing.
Yes.
You see, I am also using this Meet call on my desktop, and I am also on my mobile. Also, I am in the Meet call. So on my mobile, it is showing.
हमारे में नहीं हो रहा है सर.
सर आपकी आवाज भी कभी आ रही है और कभी नहीं आ रही.
Okay. चलो ठीक है. Take a break, okay? Take 15 minutes break.
ओके सर.
ओके
फिर try करते हैं. क्योंकि
Okay,
मुझे
sir.
इंटरनेट, I don't know, I don't understand कि क्या मसला है. Okay? 15 minutes break. After 15 minutes, you will join again, okay?